Okay, this is the practice test for part 2 of Excel, and we've got some date stuff going on here on the first tab. We want to put a formula in B2 that will always display the current date regardless of when the spreadsheet is open, and that is the today function. No arguments, just a pair of parentheses. And the birthdays in column C are date serial numbers. Format them as 14 March 2012. So the day, a 3-letter month, and a 4-digit year is what we're looking for. So first we need to select them all. And then we've got a couple of choices for doing this. We could go up here to General and choose more number formats. This is not the one that we want because we want the name of the month written out as 3 letters. So we go to more number formats. And we get the more numbers dialog box, or the number dialog box, and we want to go to date, and there's a bunch of date options here, and we're going to scroll through until we find a 4-digit year and a 3-letter month. So let's scroll down, and still not seeing it, and there it is. It's the last one on the list. Click on OK, and now everything is formatted correctly, and we're going to move on to the next question. Put a formula in column D that will compute the age that the person will be after his birthday this year. So what we're going to do is we're going to subtract the year of the person's birth from the current year. We cannot use, actually it's 2017 now that we're doing this. So we can't use 2017 as the current year. We got to use a formula. Okay. So what I want is I want to compute the year. Now actually, if you'd rather do this in 2 steps, let's do it in 2 steps. We'll do equals year, and then I want the year of whatever it is today. So that'll give me 2017 if I type year of B2. And then I can use that and subtract the year of this. So it's going to be equals, and I want this number up here, minus the year of C5. Okay, and close parentheses. And so if they were born in 2017, and I'm sorry, if they were born in 1992 and the current year is 2017, that would be 25 years. Now we got a problem here. This is actually number 25, but it's being formatted the wrong way. So let's do general here. They're trying to format as a date because we're doing some other date stuff, and Excel tries to help us out sometimes, and sometimes it doesn't help us very well. So there's a couple of ways we could have done this. We also could have, let me pull this off the side a little bit here. We could have just made use of another cell over here if you'd like to keep it really simple, so everything that's in a cell is just one simple formula. So I could take the year of the birthday over here, and then when I get here I could just put equals this number and make it an absolute cell reference, F4, minus, I don't know if I did that before, the absolute cell references. So D2 as an absolute cell minus F5. Okay. And then I want to know if they have a birthday this month. Oh, and one other way I could have done it too. Let's just delete that. And I could just put the whole thing in one phrase. I could have said equals year of $B $2 minus year of C5, and I get the same number. So I don't need to put these extra things over here, but if you think it makes it easier for you to solve the problem, go ahead and do that. And then we will copy this all the way down, and we get the age for everybody. And looks like everybody's in their 20s. So everybody was born here in the early 90s sometime. Now I want to know if they have a birthday this month. Okay, so I want to know the month of today, which, right now it's 3, but, in a few days it'll be 4. So I got to put a formula here. And again, well, let's do it with one cell first. So I want to know if the month of the person's birthday, so the month of this cell right there, which should be 11, is equal to the month of this cell up here, and that's an absolute cell reference, so I need to put the dollar signs in. And if they're equal, then I'll get true, otherwise I'll get false. So somewhere down here we should see an April. So I think there's our first April down here on row 22. So I should get false all the way down. I'm sorry, we're not in April yet, we're in March. So we should get one right here and another one right here. So it looks like row 12 and row 8 for sure, and then maybe a few more further on down. So there is row 8 and there is row 12, and it is correctly determining if they have a birthday this month. Okay, so you could just write the formula like that, but if you would rather just do two simple formulas and then put the results together in other cells, then we can do that. So we can go up here, kind of do what we did before. We can do equals month of today. And since I'm not copying that formula, I don't even have to put the dollar signs in there. So I just say month of B2. And then over here, I can put month of the birth date. Close that. And so I get 11. And then I just put a formula in here that says equals is E2. That's going to be an absolute cell reference, so because when I copy it, it's not moving. Is that equal to F5? And it should not be, so we should get false. Okay, so you can do it that way too. You will get the same answers either way. The only difference is, and I think I made a mistake here somewhere. There's got to be somebody whose birthday is, yeah, right here. Let me see what I do wrong. Is E3, oh, I didn't copy these down. Yeah, so if you want to put extra formulas over there, you got to make sure you copy them all the way down. So now this is true and this is true. Let's go on to some financial functions here. And so the gray area over here is if you invest $25,000, leave it in the bank without adding anything to it. So my investment amount here, that's going to be present value, by the way, is $25,000. I don't add anything to it, so my regular payment is going to be 0. The annual rate is 8%. I leave it in for 10 years, and I'm going to compound quarterly, so that means there's going to be 4 periods per year. And the rate per year, now I didn't have you do this on the homework, but it's real easy to do. You just take the annual rate and divide it by the number of periods. So it's C3 divided by C5. And if you take 8% divided by 4, you're going to get 2%. So that's going to be the rate per period. And the number of periods is going to be the number of years times the number of periods per year. So we should get 40 for that. And then are we doing it at the beginning or the end? We're doing it at the end, so we put a 0 in here. And then I want to know what the ending value is going to be. So that's a future value problem, and so I have to put a future value function in here. So let's go to our formulas and let's go to financial, and let's go down to future value. And the rate is always the rate per period. Remember, do not choose the annual rate. The number of periods is right here. We computed that. Payment is always negative. Put a minus sign in front of it all. In this case, it's not going to make a difference because it's 0. But if we put a different number in there, we'd want to make sure we had the minus sign in the formula. And the present value is the amount that we already have put in the bank, and that's the sum of a bunch of payments, which are negative. So that's going to be a negative number as well. So minus C1, and then the type is going to be this number down here in C8, and click on OK. And if I start out with 25,000, don't do anything, but leave it in the bank at 8% for 10 years and compound it 4 times a year. I will have slightly more than doubled my money over that time. Let's look at the next one. You borrow 30,000, so that's going to be the present value, and the ending balance on a loan is 0, and the annual rate is 10%. I've already got that formatted as percent, so you can just type in 10. The number of years is 10 years, and we're doing monthly payments, so it's going to be 12 periods per year. Now the rate per period, we've got to do that calculation. It's going to be the 10% divided by the number of periods per year, and the total number of periods is going to be the number of years multiplied by the periods per year, so that should be 120. And we're doing this at the end of the month, so we put a 0 there. Then we want to compute the payments. That's going to be the PMT function. So let's go to financial, scroll down to the letter P, PMT. And the rate, again, make sure you click on the rate per period, not the annual rate. The number of periods is 120. The present value on a loan is always positive. because that's the number, that's the amount that you have currently. So we're going to click on that. We don't need to put a minus sign in front of it. Future value on a loan is always 0, and the type is going to be down here in C18. So click on OK, and it tells us our payment's going to be $396.45, and there's a minus sign in front of it because payments are always negative. Okay. Last thing is we want to know how much of a car we can buy if we can afford to pay $400 a month. So let's put 400 in for our monthly payment. We're doing it monthly, so it's going to be 12 periods per year. We're going to take 4 years to pay it back. The annual rate is 4%. That's already formatted as a percent. The rate per period is going to be equal to the annual rate divided by the number of periods per year. So that should be 1/3 of a percent. The total number of periods is going to be equal to the number of years times the number of periods per year. I got that backwards, but I'm multiplying, so it doesn't make any difference. So 4 years, 12 times a year is going to be 48. The ending balance is what we're trying to ending balance is going to be 0, and we're doing this at the end of the month, so there's a 0 here, and we're trying to find out the present value. So how much money we can borrow right now. So that's the amount you have in your hand right now is the present value. So choose PV. The rate is going to be the rate per period. Do not choose the annual rate. The number of periods is going to be 48. Payment is always negative. Put a minus sign in front of it and click on the 400. The future value of a loan is always going to be 0, but we'll build it into a cell reference. And the type is going to be 0 for end of month. And click on OK. And it turns out that if you can borrow money under these terms, and that's all you can afford to pay is $400, then you can borrow up to $17,715, and you'll be able to pay it all back in 4 years. And we will pause there, and we will finish the practice test with a second video.